All right. So next up, we have a speaker who has apparently finally seen the light and says that the future is a graph. And this is Agata Witkowska, Senior Product Manager at Tyke. Agata, thank you so
Yeah,
much for joining us. The stage is yours.
thank you. Yeah, hi everyone. Yeah, the title of this presentation, I do realize, might sound a little bit dramatic for some of you, but there is a story behind it. Actually, I'm by nature a little bit of a skeptic. So I will probably be one of the last ones to upgrade Mac OS or Windows, or just to feel safe. And it's been like this with Graph as well for me. There's been a lot of hype in the beginning. Everyone was ready to declare rest is dead. I wasn't in that group of the people, so it took me a little bit of time to warm up to the technology itself. And ironically, I ended up as a product manager for GraphQL offering at Tyke. So I really got, it was a really long growth for me. So I wanted to actually go a little bit with you on a journey to look at how organizations work right now. First, I want to set a couple of very simple truths in place. First of all, I think most of us will agree that systems complexity will be growing the same as the size of the organization grows. There are various statistics you can find, but the more organization grows, the more the complexity of its systems will grow. I think the second point is also kind of easy to agree on, which says that well-sized or maybe smaller systems are much easier to manage, and they have less risk when you manage them than massive monoliths. And last but not least, I think we all have to remember that a modern organization, it is not just about the software that we deliver, not about the experience for the user, but it's also the software that we ourselves use every single day. Now, I've been watching the talks in GraphQL Scale earlier, and there's been a lot of talk about what I'm going to say in a second, because I think a lot of you are already knowing where this is going, and this is going obviously towards microservices, the well-sized services. I don't really want to get into much debate on how big or how the small domain should be for a service. But the underlying principle, I think, is pretty obvious. Smaller, well-defined units are just easier to manage. Now, it is also true, and I tend to agree with it, that if you're dealing with a very well-built monolith, the one that takes its solid principles very seriously, you're essentially in the similar boat as you would be with a big microservice application, right? And that's correct, but only to a point, I think, because I think where the microservices are actually really beneficial and where they really shine is in the ops and the software development lifecycle teams. So those teams that need to coordinate releases, that need to manage the costs of scale, this is where the microservices actually become very beneficial. Now, one of the obvious benefits is also speed to market. Making changes to a microservice is much easier than finding the right spot in the monolith application code. And with monolith, you also run into the risks that you touch in one place and then something unexpected gets broken, something you would never even suspect. So that brings us to my next part. And now, what are all those question marks in my slide right now? As I said in the very first slide, it is not only about the applications that we are building and shipping to our clients, but it's also about all the software that we use ourselves every single day. Now, I was actually looking through some of the statistics, and I found it really interesting that right now, on average, a company, an organization will use around 140 different SaaS applications. And it seems like a large number, but if you even split it further, you will find out that for larger organizations with 1,000 or more employees, this number can get to 300 sometimes. So we are actually talking about, customer relation management system, identity management, stock management, e-commerce, newsletters, marketing, everything, absolutely everything. And it is actually probably very, you don't even look at it every day, but you're constantly interacting with the APIs from these services. Doesn't really matter which part of the organization you are working in. If it's not an HR system to request some time off, it will be a system to send out advertising or to send out newsletters, right? Now, the key feature of a good SaaS application, of a good SaaS service, is that it will offer an API, right? Almost all of them have one to an extent. Now, do we actually really use them? So let's take a very quick look at the customer data. So you will probably have a couple of different systems that handle information about your customers from very different perspectives. You might have a CRM system that is the central place for storing information about deals, about total spend, about the organization itself. You will probably have some kind of a support ticketing system in order to manage the customer engagement and make sure that they can reach out to you with any questions or when they find, God forbid, bugs. And you will probably have a payment processing gateway because you need to make money of your application, right? So already, if you're looking at a single entity, if you're looking at the customer only, we already have information about our customers in at least 3 different systems, right? Now, there's a lot of value trapped in those systems. So in order to be able to put data in context, in order to be able to use this data to its full extent, something needs to happen, right? And this isn't a new problem. So if you remember back to the 90s, you would buy, for example, an Oracle database, you would host it yourself, or you would have a SharePoint where this data was kind of stored. Then came the cloud, and I think we are all familiar with the SaaS applications. So you can migrate it out to cloud, but you are still dealing with a massive store of value that is scattered across different applications, right? So let's see what we can do. Now, you can go ahead and start integrating, right? You can go ahead and have your point-to-point integration. So you can have your billing talking to your customer relation management system. You can have your transactional emails microservice talking to your payment system. That's all fine. But the truth is, if we look back to this average number of SaaS applications available in an average company, 140 is a little bit much. We just have 3 now on this slide. So this can get a little bit messy. Now, with solid principles, right, we can avoid this mess by using the facade pattern, which is great. Now it looks a little bit better. We only need to update the facades, right? In case the vendor decides to do an unannounced upgrade or they introduce some breaking change. But what happened right now is we essentially have added 2 more services. So we already had a lot of different services and we are only bloating them more, right? Now, this will get a little bit more complicated if it happens that you want your CRM system to talk to your support system, right? So yes, we will build a facade in front of the support system according to solid principles. However, we also need to resolve how data will be flowing between the CRM and the support, right? So we now have to build another thing, which is the connector between those 2 systems. Now, this is how you get microservice bloat. Now, some would argue that service mesh will save you here. I would be willing to say no. I think service mesh will make this diagram look a lot cleaner. But essentially, under the hood, you will be still dealing with point-to-point integrations. And you will still have the risk of one application falling over, causing a lot of problems in other parts of your system. So let's just summarize a little bit what we've done here. First of all, we need to write new microservices to properly abstract external dependencies, right? Then, if we wish to directly integrate two dependencies, we need to write the mediator. So that's the connector on this diagram. Now, my integrations actually are still point-to-point. So if I wish to perform an integration with the dependency with another service, I need to integrate with the facade. If the facade does not have the full functionality of the dependency, I need to modify the facade as well. That's a lot of work, and that's a lot of different dependencies that you really have to be mindful of. So there's one more actually pretty traditional way of dealing with it, which I've been used to in the past. I used to work as a consultant. So the solution is called, let's throw some money at it. And basically somebody like me from the past will come along and they will tell you, well, you need an ETL system to normalize and combines all your data. And then we will tell you, well, that system needs to be wired into a data warehouse, right? Okay, that's the second system. That's the second solution we need to install. And then they will say, well, now we need an enterprise service bus because service bus will provide normalization connectors for all the APIs of each of your dependencies. Now, this is it. Now you have to modify not only your microservices, but you are getting 3 new systems. And I know it's a very extreme example. You might only need 1 or 2, but your reaction might be a little bit like this. So I think at this point, it begs the question, like, surely I can do more, right? Those microservices, they look manageable. Why should I be adding more layers of software coordination to connect my stuff when I can just write a microservice and do it myself? Well, I don't think the answer is to lash it all together with intermediary services. It will definitely scratch the short-term itch, but it's not sustainable in the long run. So let's look at a slightly different paradigm. If you're using microservices, right, you are probably using an API gateway. So what if we could integrate your data as easily as a database table join? What if you had an integration layer that doesn't require you to change your upstream services? And what if you can integrate everything in the same layer? What if you didn't have to write a new layer to integrate it? And now, I would love it for everyone to use API Gateway for that, but that's also not the way. And I realize I talk about a lot of different solutions that are not the way, but we'll get there in a second. The thing is, if you try to do this, what you're essentially doing is changing API Gateway into a new monolith, right? You need to pack a lot of business logic into the gateway. You are potentially dealing with vendor SDKs, and there's a lot of vendor logic that needs to be baked into your gateway as well. So that's not really the ideal solution. And this is where we get to the part where I see the light. Because I actually think, and it's not only me, we at Tyke actually think that GraphQL really shines when it comes to being the integration layer. So we all know the history of GraphQL, backend for front end, perfect for mobile application. This is how the whole idea started. But let's look a little bit closer. So there are a couple of issues. First of all, with GraphQL, it's not so easy to predict the path a query will take. You need to think about deeply nested queries, obviously. They can potentially cause a denial of service attack. And you actually need to worry a lot about exposing the data that you really don't want to. Securing GraphQL has gotten better. I think Tyke actually does a great job of it. So all of a sudden, you've got all the freedom of getting what you want, when you want, how you want. But it also means that you're exposing all those options and all those possibilities to a client app. And the thing is, you don't have control over the app, which is a little bit scary sometimes. Okay, so what else could we actually do? I think when it comes to GraphQL, it has all the hallmarks that you need for it to become a very extremely powerful integration language layer. So here's a couple of things. First of all, GraphQL normalizes data for the requests to JSON. It's specified by the GraphQL in the schema, and the schema is strongly typed. Second of all, the mediation happens in the resolver. GraphQL also provides a standard interface to interact with multiple services, and that actually is normalizing the client code significantly. It can handle message queues and real-time event subscriptions. This is sort of like an optional component. It doesn't have to contain subscriptions, but it can. And also with good resolvers, it's possible to stitch data together between schemas and create a single graph. Now, you would think, Eureka, we've solved the problem, but I kind of glossed over a few things. First of all, let's look at the pros first. So, if we think about using GraphQL as an integration tool, as a light integration layer, all of a sudden we come to a point where, we have no more proprietary connectors. We have very few concerns around compatibility and upgrades for our system. There's a self-describing, discoverable, unified query language for all our data. It looks great. This is the pros. There are a few things that I kind of missed. So it is great. There are some real problems that we still have to solve with this idea, because it is great if you use GraphQL in a greenfield context, right, with your new applications. Think back to those 140 SaaS applications that your organization might be dealing with every single day. As long as they provide you with the GraphQL API, that's all perfect. But let's be honest, it's not going to be that way, right? The next thing, you still need to manage third-party APIs, right? So whenever the SaaS application is not offering you GraphQL, you will have to manage that third-party API. And actually, if you need to write resolvers for all your pre-existing REST and gRPC APIs, it means you're still adding more microservices, right? And that was not the point at the beginning of this presentation. So maybe we haven't quite reached the API first integration panacea yet. I have to say that we at Tyke actually have spent a lot of time thinking about it, and we still do. There's a lot of conversations we're having daily. And we are actually pretty convinced that APIs are the integration paradigm of the future. If you could achieve with a GraphQL data, if you could have a GraphQL data layer to handle all your integration and you just plug in your external and internal data sources, it would be insanely powerful. So you just think about the schema, you know what your graph looks like, and then you take the data sources, internal and external, to power your types, to power your schema to return whatever you want. And because we think it is the song of the future, let's call it, we actually went out and built it. So it's called Universal Data Graph, one schema to rule them all. You can scan the QR code if you want. It will lead you to a short video that will show how this black magic is working. But basically, it's not black magic, really. We have introduced a very low code platform that allows you to design your schema, that allows you to connect the data sources to power that schema. We take care of all the resolvers for you. So you just have to think about what you want to integrate. Currently, we support REST, GraphQL, Kafka, and SOAP. So you can take any of those data sources and just plug them in. And the best part is when you're done doing that, Tyke is actually a full lifecycle API management tool. So you can, within minutes, secure your new graph that you just designed and built and stitched together. And yeah, and it works. So that's my take. That's my take on the on the beautiful world of GraphQL and what it can be and become.
Amazing. I had so many feels throughout the presentation of things that I've thought about in the past and been cringed at in the past with microservices sometimes. So yeah, let's do a round of virtual applause in chat. And then let's talk questions. So be sure to ask your questions over in chat. One question that I've kind of got, I love the slide at the end there that was like, no, but actually yes. So are there situations that you would recommend going away from, say, a GraphQL interface situation and stick with like previous ways of doing it, or are you all in on the graph at this point?
So this is a good question, and I love those kinds of questions because it's always easy to answer them. You always say it depends. My personal opinion, my personal opinion on the topic is this. I think there's, especially in the beginning when GraphQL was first open source, there was a lot of hype and everyone jumped on GraphQL. I was, as I said, I wasn't in that group. And I think, first of all, you need to really think about if GraphQL is something you can use in your current tech stack. If your consumers are able to actually develop systems or develop a way of consuming those this information. The thing is, and because we know, so when it comes to universal data graph, when it comes to what I was talking about, I'm advocating for using GraphQL as a very lightweight integration layer for your data, right? But we at Tyke, we are very, very familiar with some of the issues that especially heavily regulated industries will have with GraphQL. So we also offer a way of integrating all of, let's say you have 10 different REST data sources, you integrate them into one graph that obviously needs to make sense. And then because you don't want to expose GraphQL for whatever reason, you can then persist certain queries back to REST. So it really is, you get from REST through GraphQL back to REST, which actually might be a very seamless way for your consumers not to even know you're using GraphQL. Nobody needs to know that. So yeah, so we really advocate enterprises to take a look at GraphQL and think about it as an equalizer.
Awesome. So I'm not seeing any additional questions coming in. So I 100% appreciate the knowledge share and for you being here today. Thank you so much and have a great evening.
Yeah, thank you.